Hello viewers, today now I discuss this idea of important topics in real analysis that is called infinite series, and we consider this idea today the convergency of the series and testing of convergency. Then how to discuss these convergent and divergent properties. At first let's watch some of the interesting series. At first, if we consider this type of series, summation r runs from 1 to up to n, and what happens there, and if we consider with this suffix, that is r, how to analyze this series. At first, if we take it for the value of r is equal to 1, next sum 1, then it's 2, then it's 3, and successively dot 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 in this way, and the last term is n, and we already know this series in our senior secondary level, that is called the AP series, and we know sum of this AP series from the natural numbers is n into n plus 1 by 2. And if we test this series, and if we take naming this series as Sn, as n into n plus 1 by 2, and that goes to infinity as n tends to infinity. As we know that n tends to infinity, and that whole series converges to up to infinity. And in other words, we say that S infinity, that will also be an infinity. And this is obviously a case of divergent series. And we give some of the idea about the divergency. We conclude we don't find any result. Now someone asks this question: if this is divergent, then how can we get the total result? Because if we consider it as a finite series, take it as a finite series, obviously this finite series by definition it is convergent. So if taking the convergency term, if we take the sum of the three terms, and if we consider it sum of the three terms, that is 1 plus 2 plus 3, that is 6, in this way we can take it successively. Finite series is finite, but here the case of divergency we find. Now in the next stage, if we considering another case, that is the case of oscillatory sequence and how this sequence is conforms, let's watch. If we simply taking in this manner, that is summation r goes from 1 to up to infinity and minus 1 whole to the power r plus 1. If we take in this manner, what happens there? If we take r is positive, it will be 1, then r is 2, negative term, next positive, next negative. So in this way we can take up to this series as infinite extent. And if we taking this name of the series here at up to infinity, so two cases arises. First one is if we take this even number, that is 1 minus 1, that will obviously 0, and if we take an odd number, that will be 1, and if we name it as Sn, if Sn equals to sum of r goes to 1 to up to n minus 1 r plus 1, and then taking as limit as n tending to infinity Sn, and obviously that goes from sum of r equals to 1 to up to infinity minus 1 whole to the power r plus 1, and there's a branch of statement arises if we consider taking it as a positive and even and odd cases. If we take the even number of cases, obviously it will be 0, and if we take an odd number of cases, that is 1 if n is odd, and 0 if n is even. So that is the cases of oscillation. So oscillatory sequence is improperly divergent. It is not convergent. It is the idea of divergency. We find it. And in the next cases, in next video, I will discuss the type of the convergency series and few interesting cases and branch of the statement. Now here we end our discussion today. If you like this video, like it, share it, and always subscribe the channel. Thanks for watching.